Let's do an example of Gauss Jordan elimination. Let's think about this matrix. Notice that this matrix comes from this system. This matrix is the augmented matrix of this system, but the process of Gauss Jordan elimination is independent of the fact that the matrix comes from a system. Then let's just think about this as a matrix and let's start the procedure. The first step is you look at the first column. Then you have to look for a candidate for a pivot. And we see that this one in the third row is a good choice to be a pivot. Then in this case, the first step, we're going to change row 1 and row 3 so that this pivot is on the top. And we have 1, 0, 4, 5, 5, 5, 7, 24, negative 7, negative 6, negative 12, negative 33. Now we use this one to put zeros in here and here. We have to use the pivot to put zeros for the rest of the entries in that column. Then to do that, we will change row 2, and we will change it with row 2 minus 5 times row 1. Right? And to put a 0 here, I will change row 3, and I will add to row 3 7 times row 1. Then we get the matrix. The first row is not changing, 1, 0, 4, 5. And here, when I multiply by negative 5 and add, I get 0, 5, negative 5 is negative 20, plus 7, negative 13. And when I multiply by negative 5, I get negative 25, plus 24 is negative 1. Okay, we have this. And then here, to get a 0 here, I multiply this row by 7 and add. Then here I get 0. 7 times 0 minus 6 is negative 6. 7 times 4 is 28. Minus 12 is 16. And 7 times 5 is 35. Minus 33 is just 2. Then we have taken care of the first column. Then we look at the second column and we can try to see if we can find a pivot, right? And here actually there are 2 pivots that can be used, but let me do something first so that I get a better option for a pivot. One option could be to multiply this row by 1/5, and if I do that, then I will get a 1 here. I want to get a 1, but maybe something that I can do instead is I'm going to change this row by the sum of the 2 rows. Let me do that. Let me change row 2 by, let's say, row 2 plus row 3. I want to get a 1 and I don't want to deal with fractions so early. Then I have 1, 0, 4, 5, and here I have 0. I will be getting here a negative 1. Here it would be a positive 3, and here you will get a 1, and here this 1 stays the same. Now this is a better choice for a pivot. Let's just multiply this row by negative 1. Then that's labeled as negative row 2. When I do that, I get 1, 0, 4, 5, 0, 1, negative 3, negative 1, 0, 6, 0, negative 6, 16, and 2. Now I use the pivot in the second column to make the other elements in the column equal to 0. This is already a 0, and I have to make this a 0. In order to do that, I will change row 3, and I will add to row 3, I will add 6 times row 2. When I do that, what do I get? I get these 2 rows stays the same. This row stays the same. And this row, it changes with 6 times 1 plus minus 6 is 0. And here, 6 times 3 is negative 18 plus 16 is negative 2. And here, 6 times negative 1 is negative 6 plus 2 is negative 4. Then, now, the second column is taken care. Now I move to the third column, and I have to look in this part of the matrix to see if I can find a pivot here in this part. And actually, this will work as a pivot, this one here. And then I will do the change. I will multiply by negative 1/2 row 3, and then I will get the matrix 1, 0, 4, 5, 0, 1, negative 3, negative 1, 0, 0, 1, and 2. Now that I have this one here, I will use this one to make the rest of the entries in that column equal to 0. And I can accomplish that by changing row 2 by adding to it 3 times row 3. Another change that I can do, I can change row 1 by adding to it negative 4 times row 3. Then when I do these 2 changes, I get the last row is not changing. The second row, I am going to multiply this by 3 and add. Then I will get 3 times 0 plus 0 is 0. 3 times 0 plus 1 is 1. 3 times 1, 3 minus 3 is 0. 3 times 2 is 6 minus 1 is 5. And now I will change row 1 by subtracting 4 times row 3. If I multiply by negative 4 and add. Negative 4 times 0 plus 1 is just 1. Negative 4 times 0 plus 0 is 0. Negative 4 times 1 plus 4 is 0. And I'm multiplying by negative 4. Negative 4 times 2 is negative 8. Negative 8 plus 5 is negative 3. Okay, and now when you move to the next column and you move down 1 row, this is it. There are no more things to do. This is already in row reduced. This is row reduced echelon. Okay. Now that we have the row reduced echelon, let's find the number R. The number R indicates the number of rows that has a pivot. Right? Number of rows that has a pivot. R is the number of rows with a pivot. And in this case, that number R is 3. D is the set of indexes. This is like columns with a pivot. But in this case, you should label the number of the column. In this case, column number 1, 2, and 3. They have pivots. Remember that these are the 3 pivots. And then this set of indexes would be column number 1, column number 2, and column number 3. And F is the columns without a pivot. And it just refers to the indexes. In this case, we have that column number 4, then the fourth column doesn't have a pivot. Okay, this is about doing the row reduction using the Gauss Jordan. But let's suppose that we were interested in solving the system. If we are interested in solving the system, we know that this is the augmented matrix of this system. And therefore, since all of these are row, and therefore, since this matrix is row equivalent to this matrix, that means that the system associated with this matrix is equivalent to this system. And what is that system? Let me just erase this here. Let me just keep this. That system would be the system x1 equal -3, x2 equal 5, x3 equal 2. That means that the solution of this system would be, the solution set would be the set -3, 5, and 2. Remember that every system has either no solution, or it has exactly one solution, and it has infinitely many solutions. Let me remind you that a system with no solution, is called inconsistent. But this is not the case here. And we have that a system with a solution, and we also have that if a system has either one solution or infinitely many, if a system has either one solution or infinitely many solutions, then the system is called consistent. Then we have the meaning of inconsistent and consistent. And in this case, this system would be consistent. Okay, this is it for this video. Do this homework.